Okay, let's look at antiderivatives and indefinite integrals. Right. So here's the definition of antiderivative. Right. So capital F of x is called an antiderivative of lowercase f of x if capital F of x prime of x is equal to lowercase f of x. Right, so basically antiderivative is the function whose derivative is f of x. All right, so for example, right, so let's do a simple example. Let's say lowercase f of x, original function is 3x squared. Right, can we think of a function whose derivative is 3x squared? Then we can play around and define that x cubed would give you the derivative 3x squared, right? But the problem is that's not the only one. You can try something like x cubed plus 1 or x cubed minus 5, right? Or we can just add any number, any constant to x cubed. We still get the same derivative. So in general, we write it as x cubed plus any constant c, right? So this is a family of antiderivatives of 3x squared, right? So this is called antiderivative, and there's a convenient notation called the indefinite integral, right? So we're going to use this notation, right? So this is a kind of a elongated S sign. So this is called the integral sign. So maybe I should mention that. So this is called the integral sign, right? And the function inside, this guy right here, it's called integrand. All right, and dx tells you you're taking a derivative with respect to which variable. This is called the differential. All right. So this is basically the antiderivative notation. So we take the antiderivative of lowercase f of x with respect to x is equal to this capital F of x is any antiderivative plus some constant, and this guy is called the constant of integration. So it's just any constant. So constant of integration. All right, and where capital F prime of x is equal to little f of x. All right, so for example, notation wise, we can write this. If you say integral of 3x squared dx would be x cubed plus some constant c, right? And another easy one would be, we know that the derivative of e to the x is e to the x, right? So if you take the derivative of e to the x, you will get e to the x, right? So which means that if you take the antiderivatives of e to the x, you will get e to the x plus some constant c. Right? So that's how we use indefinite integral. So basically this is for antiderivative notation. Right? That's it. I hope that this was clear.